three separate force vectors of acting upon him. So we've got to find the components of each of these vectors. So for the group of minions, I know that if this angle is 20 degrees, then my angle from staying position is going to be 160 degrees. 180 minus 20 is 160. So to find the components of the group of minions, I take their force, 21 pounds, times the cosine, 160. That's the x component. And 21 times the sine of 160. I put this into my calculator and I get an x component of negative 19.734 and a y component as 0.182, which makes sense because this is a value in the second quadrant. Next, we look at the group, the two minions. They're in the third quadrant. So to find their angle, I'm going to take 180 degrees. I'm going to add 50, which is 230 degrees. So I'm going to take their force, which is 6, times the cosine of 230 degrees, and 6 times the sine of 230 degrees. The component form is magnitude cosine of your angle, and magnitude times the sine of your angle. And the components, they should both be negative because we're in the third quadrant. These minions are in the third quadrant. Is negative 3.857 and negative 4.596. And then this very last min is along the x-axis at 0 degrees. So 12 times the cosine of 0 degrees and 12 times the sine at 0 degrees gives me a horizontal component of 12 and a vertical. Now the next thing you're asked to do is find the resultant vector. What is Tom Brady's resultant vector? So I add up all three of these forces and I get an x component of negative 11.5 and a y component of 2.586. So if I want to determine the resultant speed, then I have to calculate the magnitude. Well, magnitude is Pythagorean theorem. If I think about Tom Brady vector, he's in the second quadrant. His resultant vector is in the second quadrant, 11.59 and 0.586. Here's his resultant vector. So I do Pythagorean theorem with his x and y. So the magnitude is the square root of negative 11.59 squared plus 2.586 squared. I put this into my calculator and I get that Tom Brady moving at a speed of 11.875 feet per second. Now his angle, his direction angle, is going to be this value. Well, I'm going to find the theta, the reference angle, inside my triangle I've set up by doing inverse tangent of y over x. So 2.586, his y component over his component. Opposite over adjacent. SOHCAHTOA, opposite over adjacent. The opposite side was 2.586. The adjacent side is 11.59 to the left. And this gets me a theta value of negative 12.578. It's negative reason because it's in the second quadrant. I'm going to add 180 degrees to this to get my final direction angle of 167.42 degrees. If I'm going to rewrite this as bearings, okay, then I need this from north moving west. So I take the 12.578 and I'm actually going to add the 90 degrees to that negative 12.578. So my bearings are going to be north 77.42 2 degrees west. That's this angle, the complement angle right in there. He's north, right here, moving 77.42 degrees to the west, rotating towards the west. All right, so put it all together, and we write Tom will be moving 11.875 feet per second, headed north 77.42 degrees west. Now in these last 3 scenarios, all we have to do is talk about what is going to happen. I don't really expect you to recalculate all of these. So what would happen to Tom's magnitude and direction if we took out the group of minions? Well, if we took out that group of minions, he's going to be moving slower. This had a large force to it, 21 feet per second. He's going to be moving slower, and he's not going to be pulled into this lower quadrant. He's going to be pulled more towards this southeast quadrant if these guys are no longer here. Okay. Now let's look at what happens if we take away the pair of minions. So we take away these guys. Okay, so once again, these guys were pulling him more towards the west. Okay, so now he's still going to be moving slower. He's going to be going less west and more north. These were the only guys moving towards the south. So if I remove these, then he's not going to be moving towards the south anymore. He's going to be going more north. And then what if I take away just the single guy up here that only had a horizontal component? This guy was resisting these 2 other vectors. So now Tom will be moving faster and more west. There's no vertical change that's going to happen. I hope this was helpful.